looks very similar, but a little bit different than any of the ones that we've seen in the past, because this particular one has 3 side links compared to some of the other ones that have all had angles. So hopefully you remember that we've been talking in depth about what is necessary in order to solve any triangle, and that's 3 parts. You have to know half of the entire triangle, and at least one of those has to be a side. In this case, all 3 of our pieces that they gave us are sides, which means we need to know angle A, angle B, and angle C. And if we find the first 2, then we should be able to find the third. And so I was able to help you guys to find a formula that would allow us to find the angle measurements. And those are all here in the upper right. These will allow us to skip all of this. Now, if you're one of those that doesn't really like to work to memorize things, then as long as you have the law of cosines, the original form, memorized, then you can always solve for the angles. So no big deal either way, but yes, we are going to have to use our law of cosines again, because obviously we do not have a good ratio of an angle and a side that has the same letter. So in this case, I'm going to have to take all 3 of those sides and utilize my law of cosines. Now, the question that we need to ask ourselves before we start this is, which one? Which one of those 3 angles should we solve for? And does it really matter? Well, yes, you can actually hurt yourself in the long run by not finding specific angles. And which angle do you think would be the best to find? Hopefully you thought about it and came up with the biggest, because the biggest angles are the most difficult to deal with sometimes, especially when they're obtuse, because not all of these, like we talked about, are going to be right triangles. Most of them are going to be oblique. So I'm looking at these things and I'm seeing that 59.3 is the biggest side, so that angle C would be my biggest angle. So I'm going to do my law of cosine adaptation, which I solved for you guys earlier and we derived for just the angle. Since I already have it, I might as well utilize it. Hopefully you guys remember what it was though. It was a squared plus b squared minus c squared over 2 times ab. And because we have a, b, and c, we can plug all that in. And since we're trying to find an angle, we're going to have to use what? That's right, the inverse. And then we can go ahead and use our calculator to find out what all those are. And now that we have it all plugged in, careful again with your calculator work. The most missed part of all of these problems with students is typically the calculator work. All the other stuff they can set up is just be very careful, okay? Unless you put a big parenthesis or bracket around the top, if you just hit all of that in order and then put divided by, it's going to divide by 2, and then it's going to multiply the next thing by 25.4, and then the next thing by 42.8. So if you're ever wanting to just put all of that into your calculator, go for it, but just make sure you have the extra set of parentheses. And then when you get that big old nasty number out, remember, in order to find what angle C is, we're going to have to take the input and the output and reverse their order, which means we got to use the inverse. And when you do that, you'll be able to find angle C, and it should come out 118.6 degrees, taking it to the nearest 10th, even though we only have 3 sig figs. Make sure you read the directions so that you know what to answer. Otherwise, we would have put 119 for 3 sig figs. Okay? So now that we have that angle C, we can utilize the fact that we know side C and use our law of sines. We don't have to use law of cosines more than once. So I'll go over here to the side and say, well, let's find the next biggest one. Not that it matters now, but let's go and find angle B. Now, in order to take this and solve for angle B, the one unknown in this, I'm going to multiply over. So that cancels out. and I get the sine of B is equal to some number. And now that I have that number, I will do the inverse to reverse my input and my output, and that will then allow me to find what angle B is. And I found that angle B after computing it is 39.3 degrees. And because I now have two angles, I don't need to use the law of sines, law of cosines, or anything else with that. I can just use the fact that I know the sum of the angles of a triangle is 180 degrees. And angle A, if you do that in your calculator or off to the side, would come out to be 22.1 degrees. And we have now found all the three unknowns and therefore solved triangle ABC given the side, side, side scenario. All right. Not too bad. A lot of little calculations. And like I said, be very careful of your calculator work. That's where most people will make mistakes. All right. So how can we utilize this in real life? Well, hopefully, if you've ever driven by a house that's being built, you can see that they'll have a bunch of triangles. They're called trusses that are up there to take the load of the weight of all of the stuff that they're going to put on top of it to protect yourself and all of your valuables in your home. So they're going to give you a little drawing like this to kind of show you how you can do this. And then they're going to tell us a certain length for each one of these things. So it says, find the angle in the lower right-hand corner. So we're looking for this angle right here. For this truss to the nearest degree, if the two diagonal side lengths are 9 feet and 6 feet. So one of them is 9 feet. This one over here, 6 feet, because it looks a little bit smaller. And the base, the one down below on the bottom, would be 11 feet. So hopefully you can see that this is the exact same type that we just did, except now we want to find this angle rather than all of them. So same type of idea. Hopefully you guys can do it without even labeling, but if not, go ahead and label A, B, and C, and that'll help you. So since I'm trying to find that angle there, if you want to label it, like I said, that's fine. A, B, and C. Then this would be little c, this would be little b, and this up here would be little a. And since we're trying to find the cosine of angle C, so again, without actually putting those letters so that we can solve a little bit faster, the other two would be the 6, the 11 for each. And then the one that we're going to subtract off is the one that we're trying to find the angle of, which would be the 9. And so we will have cosine of angle C equals some number after punching all of this into our calculator, which a lot of this we can do on our own. And then obviously we're trying to find the angle. So we're going to have to use our inverse to take this number and the angle C and reverse their order. So we'll do the cosine inverse of whatever that number is, and it will now equal angle C. And when you do that into your calculator, you will find, remember, to the nearest degree, rounding to get 55 degrees. So again, not too bad. This one, we actually get to stop there. We don't have to find all of the other missing parts. So cool little application, very quick, very easy. Now, hopefully you are seeing why I suggest that you actually memorize that form of it, because we are going to have to solve for angles every once in a while with this law of cosines. So on to the next type, your favorite, when we're out at sea. Now, I know when you're out at sea, it's very difficult to see a lot of these, which is why it's very imperative that you can draw them and draw them to scale correctly. So make sure that you don't draw it too small so that you can't see what you're actually writing in, or draw arrows to it so that you can make sure that you have the correct angles. So what we're going to have to start by doing, drawing it out, giving ourselves a visual. So say we start at some angle and we had an 82 degree 20-minute angle between the two boats. So if you wanted to draw one just going horizontally, that's fine. Then the other one wouldn't quite be a 90, but pretty close. So something like that. Now I drew one a lot smaller than the other, but now I can write in 82 degrees. Instead of 20 minutes, hopefully you remember 20 minutes, we can always multiply by 1 in our fancy looking one. If we want to get rid of the minutes, then we're going to have to divide by the minutes and change it to degrees. Now that ratio, that is a fancy looking 1, would be, we know for every 1 degree, there is 60 minutes. And that would allow those to cancel out, and we get 20 over 60 degrees, or 1/3 of a degree, which we can write as 0.333 repeating. So however you want it, that's why they put 20 minutes, because 0.333 repeating is kind of nasty. Now don't forget 1, 2, 3, 1, 2, 3, 1, 2. This we cannot count because it's a 0. So there's actually 3 significant digits on this. So I'm going to put 82 degrees 20 minutes for now, but if you wanted to change it, then you can obviously just keep the 0.333 degrees. Okay. Now, the other thing that we're going to have to do is label, which they told us the slower boat was going 62.5 kilometers at the end of the time, and then the other faster one had gone 79.4 kilometers. And what they wanted us to do was find the distance between them from there to there. So again, if you want to label A, B, and C, X, Y, and Z, it's totally up to you, or don't label it at all. But hopefully you notice that we have a side included angle and side scenario, not the side that we've had the past 2 examples. So for this, I'll go ahead, since I already have that A there, I will go ahead and rewrite this all as angle B and angle C. And so what we would be trying to find is little a this time. So my law of cosines, that now allows me to be able to find side length A if and only if I take the square root of both sides. That will then give me, after a bunch of computation, which as I mentioned, I like to do it from right to left. I like to find the cosine of my angle first, multiply it by these things second, and then add that third, fourth, and then take the square root fifth. That will hopefully help you to not make mistakes. Now, if you want to do this all at once, then just add in a big old set of brackets or parentheses around all that, and then have it take the square root. Okay? Whatever you do, it's totally up to you. Just be careful and make sure that your answer makes sense in size, but we should have found that this is 94.3 kilometers. And again, 3 significant figures or digits for our answer. All right. So again, not too bad. Hopefully you're feeling a little bit more comfortable as we progress through this video, and also as you practice these law of sines and law of cosine solving oblique triangles. But here's one more thing that we talked about earlier on when we first learned the law of sines, and that was how to find the area. Now, the other one that we found the area of was our typical 1/2 base times height, but that was only for right triangles. So then we came up with that alternate version where we actually used our law of sines and went and tried to find it. Well, there's a Greek philosopher, mathematician named Heron that actually came up with a very ingenious way to find the area of a triangle, any triangle, when you are only given 3 sides. Now, I'm not going to derive this one for you simply because it's very labor intensive, and I don't think it would do you guys that much good, because we're not going to use the area when we have 3 sides a whole lot, like we will as we continue on with this class for the law of sines and the law of cosines, which is why I took the time to derive those. So for this one, I'm just going to quickly explain it. We'll do an example, make sure that you got it down, and then you guys just need to practice. So he came up with a way to find this length of S, which he called the semiperimeter. Now, you know a semicircle to be half of a circle. So the semiperimeter is when we take the perimeter of this whole thing by adding up all three sides, and then we take half of it. His formula to find the area of a triangle with three known sides that is a non-right triangle is this. You have to take the square root of the semiperimeter, and then you got to find the difference of the semiperimeter with each one of your side lengths, and then multiply all four of those things together, and then take the square root, and that will always give you the area. So again, if you want to check it out, then you can look it up on another video or even in our book, and most books will have the derivation of it. I just don't think it's worth our time. So let's do an example in order to find it. So again, this one looks very similar to some of the other problems that we did. So I tried to bold, even though they won't always do that. Make sure you answer what they asked for. Don't just look at this and go through the motions and start solving the triangle for all three angles. They didn't ask you to do that. All they wanted us to find was the area of this. And notice they gave us three side lengths. So the first thing I'm going to do is find that thing called the semiperimeter, which is where we take the perimeter, which for our three side lengths were 22, 45, and 31, and then we'll take half of that. So adding that all up, and we need to take 1/2 of that. Now that would have been really nice if we had half of 100, because we know that. That's 50. So since we have one less 2 there, hopefully you know that that would be 49. Either way, however you get 49, we know that that is what is called our semiperimeter. So in order us to find the area, we need to take the square root of that times that minus each one of my three side lengths. So I'm going to start by putting in that semiperimeter of 49 in all four of my parentheses. And then I'm going to subtract the side length of each one of those things, which was the 22, 45, and 31. Then you punch all of that into your calculator and you will get your area without having to find the height and using one of those as the base, and saves us a little bit of time. So thanks to Heron for actually finding that for us. Now we can just tell them that the area is 310. Now notice I'm using two significant digits, so I actually rounded that to 310, and because they were all in inches and it's an area, it would be inches squared. So not much to that one. You just got to hang in there. Make sure that you're careful. One of the biggest mistakes that people make is right here. They forget the semiperimeter for the very first one, and they'll just do the difference of each. But other than that, careful with your units, calculations. And just to summarize all of the stuff that we've talked about, I wanted to make sure that you can see the four cases that we have here. And so this is mainly just for your notes. All right. Take this and utilize it however you want. All right. But just to kind of hit the high points on it, if we have just one side, like we've been talking about, whether it's angle side or angle side angle, remember you have two angles, so it's very easy to find the third because we know the sum of the triangle is 180. So you can do that and then find the remaining side that you needed for either one, A, B, or C, by using the law of sines. Case 2 was that really special case, which I wrote the other direction, just to remind you, hey, whenever you have angle side, you don't want to look like one of these. Make sure that you check for that ambiguous case. All right. And when that happens, remember, you don't have to do anything special. You don't have to actually memorize a bunch of stuff. The key to this is just knowing, can I actually make another triangle? All right. And so with that, find the angle. Once you find the unknown angle, take that and find its supplement. And once you found the supplement, then see if that allows you to actually use the original angle that they gave you into making a third, which again, you know it has to be less than 180 in order to make a second triangle. If it's over that, then you can't. Pretty simple, not too bad. And remember, these are when we're going to be using the law of sines for these cases. All right. The other two, which we just went over, side angle side or side side side, is our law of cosines. All right. The only one that I want to highlight here is the fact that we need to make sure that we are finding the largest angle whenever we have those three sides. Find that first and then find the remaining angles. Okay. So hang in there, start memorizing these things, and it'll go a little bit faster for you. Otherwise, continue to look them up and make sure that you can plug in the stuff to your calculator correctly to find the missing parts. I wish you all well. Hang in there. Keep working hard. Alan, out.